Here are the solutions to the Chapter 2 study guide worksheet. Again, 12 through 15, we just had to identify the domain and range. Remember, when it's listed as relation, we just list the domain and then we list the range. If any x values or y values repeat, we just list them once. Now, 14 and 15 were both linear equations, so I got them both here in slope-intercept form. Now, granted, to graph these, they weren't the easiest, but 7/4 and 3/2 is y-intercepts. It's not terrible. You would definitely want to use graph paper on these. But any line that has a positive or negative slope is going to have a range and a domain. That's all real numbers. 16 through 19, we were just evaluating the function, so especially on 18 or 19, if you have any questions, let me know. I'll go over them for my remote students on at the next Zoom meeting. 20 through 23, again, not linear if we see higher exponents like an x squared or y squared, but 21 and 22 were linear. 21 graphs a decent line. It has a higher up y-intercept there at 11, slope of -2, and 22 is just a horizontal line, y equals -7. 24 through 29, we had to write these in standard form. So again, please let me know which questions you have, and I will go over them at the Zoom meeting. And then to continue on to the domain and range worksheet B, 1 through 4 is all you had to do. Again, please let me know if you have any questions. All right, so what we're going to look at today is our focus today and tomorrow is going to be on going back over how to write equations of lines. So sometimes we need to find the slope given 2 points. We will write the equation of a line in slope-intercept form from various conditions, meaning we might be given the slope, we might not be given the slope, and then to write equations of lines using this point-slope form that I first introduced in yesterday's lesson. So let's go ahead and take a look here. Just to revisit all 3 forms. So we have slope formula, which is that y2 minus y1 over x2 minus x1. Please keep in mind, it's rise over run, so it's the y's that go in the numerator. Change in y's over change in x's here. Slope-intercept form, as we saw yesterday, y equals mx plus b. And then point slope form, which comes from a rearrangement of the slope formula without the y2 and x2, without the little 2's there. So it's y minus y1 equals m times the quantity x minus x1. So again, we're going to use slope-intercept form and point slope form to help us. You guys pick which method you like, and then you just use one. I'm going to keep showing both, though, but you pick one. All right, so our first example, pause the video to copy this down. We're going to write the equation of a line, ultimately in slope-intercept form here. So I like to show 3 things. I like to show if we need to calculate the slope, we show our work. If not, we just write what the slope is. And then we use, this is one way to do this, we want to find the y-intercept. So you could use y equals mx plus b to do that. Or this new technique, we're going to use point slope form to help us out. And then eventually we write our equation. All right, so here our slope is given to us. It's 3/4, and then we just know it passes through the point 12, -5. So right now, I'm just going to indicate our slope is 3/4. If I want to use y equals mx plus b, this is my x, this is my y, and then I have my slope here. So my y, we have to be careful. Y is -5, so I'm just going to write this out. Y equals mx plus b. Y is -5. M is 3/4. X is 12, or 12 over 1, and then we have to find b, so b stays a variable. So this becomes -5. We just have to be careful multiplying fractions here. 2 ways you could do this. You could do 3 times 12 is 36 divided by 4. You could say 4 goes into itself once and then 12 3 times. Either way, we're going to get a 9 plus b. Next, we're going to subtract 9 from both sides, so this will give me a -14. So right now, my equation, I have it as y equals 3/4 x minus 14. Now, how does point slope form work? It works as an alternative to what I just did here using y equals mx plus b. So if I start with y minus y1 equals m times the quantity x minus x1, the first y stays a y. My y1, again, is this -5. Same thing that's up here. So I get y minus a -5. We just have to be careful when we subtract a negative. Equals our slope, which is 3/4, times the quantity x minus x1, which is x minus 12. So now the left side becomes y plus 5. I'm going to get 3/4 x. I distribute the 3/4. This will give me, again, a 9. And now my very last step, so when I multiply 3/4 by negative 12, I got a minus 9. My last step is to get y by itself, so I just want to subtract a 5. So when I do that, I get y equals 3/4 x minus 14. So here it takes all the information we're given, and the final step, as we solve for y, it turns it into slope-intercept form. So we have both of these equations match, which is a good way to double check as well. But again, you choose this way or this way. You don't have to keep doing both. All right, so if you want to pause the video and give this a try, it's very similar. Again, we want to identify or calculate our slope, find the y-intercept using y equals mx plus b, or you could try point slope form, which is y minus y1 equals m times x minus x1, and ultimately we'll write our equation. All right, so our slope again here is given 1/3. If I want to use y equals mx plus b, again, this is my x and my y. So 5 is y, my m is 1/3, my x is a -2 or -2/1 plus b. So now I'm going to get 5 equals -2/3 plus b. Now if I want to add 2/3 to each side, it might be helpful to turn 5/1 into something with a common denominator, which would be something over 3. So let's turn it into 15/3. -2/3 plus b. So now when I add 2/3 to each side, I'm going to get 17/3 for b. So sometimes, and unfortunately, we have to work with these fractions. So my equation now is y equals 1/3 x plus, that should be an equal sign here, 17/3. All right, if I used point slope form, now this is my x1 and my y1 here, so the first y stays a y, then it's going to be minus 5 equals 1/3, which is my slope, times x minus a -2. So now this becomes y minus 5 equals 1/3. I want to rewrite this as x plus 2. So now I'm going to get y minus 5, distribute the 1/3, so I get 1/3 x plus 2/3. Now technically here, and I could have done this over here too, 5 plus 2/3, I could just leave as 5 2/3. So that's what I could do here. Y equals 1/3 x plus 5 2/3. So now the question is 17/3 the same as 5 2/3? So if you guys remember, we could do this one of two ways. We could say, well, 3 goes into 17 5 times, and that's 15, so there's 2 left over. Or if you start at the 3 and work backwards here, you multiply 3 times 5, then you add 2, so that's 17, and then you keep it over 3. So yes, 5 2/3 is the same as 17/3. So we could leave it as 5 2/3. It's just not every mixed number we write is a true mixed number. So this is fine. And this is actually nicer to graph. We know we're just going to go a little bit over 5.5 here. So y equals 1/3 x plus 17/3, or plus the 5 2/3. All right, let's take a look at this example. Please copy it down. So we have our slope we need to calculate here. If you notice the slope is not given, then we have to find our y-intercept. Again, we can use y equals mx plus b, or we can use point slope form. And then we'll write our equation. All right, so the slope's not given to us. This is where we use rise over run, y2 minus y1 over x2 minus x1. So this is x1, this is y1, this is x2, this is y2. Technically, I could have called them in reverse, that's fine, but this works. Just be careful when we subtract a negative. So y2 is 1 minus y1, so 1 minus a -1. And then -2 is my x2 minus 6. So I'm going to get 1 plus 1 up top, just to show that change. So I'm going to get 2 over a -8. Simplify your slope always, so we're going to get a -1/4. All right, now since I have 2 points, it really doesn't matter which one I use. I'm going to go ahead and use this first one here. So y is -1, my slope is -1/4, x is 6, or 6/1, plus b. So I'm going to get -1 equals -6/4 becomes -3/2 plus b. Now, for this case, there's two ways I could approach. I could turn this negative 1 over 1, really, to a common denominator of 2. So it's really a negative 2 over 2 equals negative 3 halves plus b. So now if I add 3 halves, just to squeeze it in down here, b is going to equal 3 halves minus 2 halves is just 1 half. Or I could have gone back to negative 1 equals negative 3 halves is a negative 1.5 plus b. So sometimes it helps do whatever's easier for you. Turn it into a decimal, and now when I add 1.5, 1.5 minus 1 is 0.5, or 1 half. So now my equation is y equals negative 1/4 x plus 0.5, or plus 1 half. Now if I want to use point slope form, again, it doesn't matter which point I use. This time I'm going to go ahead and use negative 2, 1. So when I use y minus y1 equals m times x minus x1. And again, it doesn't matter. It's going to look different in the middle doing the work, but the final result, we should still get the same equation here. So y minus y1 becomes y minus 1. Our slope is negative 1/4. And then x minus x1 becomes x minus a negative 2. So I get y minus 1 equals negative 1/4 x plus 2 inside the parentheses. Distribute the 1/4, so I'm going to get negative 1/4 x. This will give me a minus 2/4, or a minus 1 half. And then I'm going to go ahead and add 1. So y is going to equal negative 1/4 x. 1 minus a half is a half. So this equation matched this one. But you can see how sometimes it's fewer steps, sometimes it's a little bit more. Now, what's a good way to check this? We can go to Desmos, and all you have to do, so let me pause this and bring this up. I'm just going to check this one, but I'm going to show you how you could check the other. All right, so what I'm going to do is I'm going to graph the equation we just came up with. So I'm going to graph this. So right now, bring up a graphs page on Desmos and type in, you don't really need in Desmos, you don't need the y equals, but again, we're going to do negative 1/4 x plus 1 half. I just always like to type it. Let's see if this will, having to keep going back and forth here. All right, so let's do, it's going to do this. So y equals, now very careful, when you type in 1 divided by 4, see how I'm right next to that 4 in the denominator? Just hit the right arrow key to get out of that. And then we want x, and that was a negative 1/4, so I'm going to go back to the beginning, type in a negative sign, and then we want a plus 1 half. All right, so you could see my line here. Next, what I want to do is go back, and let's plot the points 6, negative 1, and negative 2, 1. So in another line, we're going to type in 6, comma, negative 1. So we see this point here in blue, and then our other point was negative 2, 1. Now you can type this right on the same one. If you hit comma right after that, and then our negative 2, comma 1. All right, so what we're checking to see here is that our line, that's what we were questioning, it definitely goes through these 2 points, and that's a good way to check. So when we go back to these others, all you have to do is graph this line, plot this point. Make sure that this line goes through this point. If it does, you have the right equation. Same thing here. Graph this line, plot this point. That line should go through that point, and that's an excellent way to check if you have the correct equation. All right, so Chapter 2 study guide, not the I'm going to call it Chapter 2 worksheet, Chapter 2 review, whatever. It's still the same worksheet that I assigned yesterday. Just do problems 30 through 36. Please read over the directions carefully, and then finish up that domain and range worksheet B, 5 through 9.